Hey there, welcome back to the channel. Today we are going to solve another LeetCode challenge, that is product of array except self. So this is the problem statement. Given an integer array nums, we need to return array answer such that answer I is equal to the product of all the elements of nums except nums of I, and the product of any prefix or suffix of nums is guaranteed to fit in 32-bit integer. So we don't have to worry about overflow, and we have to write an algorithm that runs in O of n time and without using the division operator. Okay, so we are given this array 1, 2, 3 and 4. We are given this array and we have to return an array. Array is called the product except self, we can say. So here at this position 1 in our product, what we have to store at 1. So we have to store the product except 1, that is 2 times 3 times 4, that is 24. And for 2 we have to find the product except 2, that is 1 times 3 times 4, that is 12. And at the corresponding position of 3 we have to find the product except 3, that is 1 times 2 times 4, that is 8. Then for 4 the product except self, that is 3 times 2 times 1, that is 6. And we have to return this array. And we see that in this output this is the array. And same for example 2. The product except minus 1 is 0, 1 is 0, and for 1 that is minus 1 into 1 and minus 3 into 3, that is 9. And similarly 0, 0. Okay, so for this input we should return this array. And for this particular input we should return this array, or we can say product except the self array. And we have to solve this in linear time complexity, and we don't have to use this division operator. If we are using a division operator, then what we can do is we can find the product of all the elements, that is 1 times 2 times 3 times into 4, that is 24. So we can find out the product by multiplying all the elements. And now what we can do is we can traverse the array and we can divide 24 at the value we have in the corresponding position. So here we can divide 24 by 1, then we can get 24. Here we can divide 24 by 2, then we can get 12, and so on. But in that case we have to use division operator. But in this problem we cannot use division operator. So without using division operator, how can we solve this problem? Let's see how can we solve this problem without using this division operator. Let's see how can we solve this problem using concept of prefix and suffix product. For example, we are given this array of integer. We have to return an array. That array will store product except self for every single element. So what does this mean? So if we have this array right here of same length, we will have 24, right? Product except 1, that is 2 times 3 times 4, that is 24. Then 3 times 4 times 1 equals to 12. Then we have 4 times 2 times 1, that is 8. And here we have 3 times 2 times 1, that is 6. So we have to return this array, and we have to return this array, and we cannot use the division operator. Also, our algorithm must work in O of n runtime complexity. So how can we solve this problem? So let's see how can we solve this problem using the concept of prefix and suffix product sum. So what we are going to do, we are going to construct two array. One is called prefix product. So here in prefix product array, in corresponding position we are going to store the prefix product. The prefix of 1 is nothing on the left. So by default or by base case we can say we'll insert here 1. Now let's move to the next element. Here we have 2. The product of prefix of 2 is just 1. So we'll be having just 1. At this corresponding position we are storing the prefix product of all the elements. So this element we have prefix product as 1. For this element also we have prefix product as 1. Let's move forward to 3. The prefix product of 3 is 2 times 1, that is 2. and the prefix product of 4 is 3 times 2 times 1, that is 6. So this is our prefix product array. We'll see how to construct this prefix product array using the concept of dynamic programming. Now let's construct our suffix product array. Let's call it SP for suffix product. So let's create an array right here, and we'll be constructing this array from the right side. So let's construct this suffix product array. So here we have 4. So what is the suffix product of 4? On the right we have nothing. So by default, or we can say this is our base case, we have nothing on the right. We'll assume the suffix product of 4 is 1. Now what is the suffix product of 3? That is 4. Now what is suffix product of 2? That is 3 times 4. That is 12. What is the suffix product of 1? That is 2 times 3 times 4. That is 24. So we find out the prefix product and suffix product. At this position, we see we have prefix product of 1 is 1 and the suffix product of 1 is 24. And similarly for 2, the prefix product is 1 and suffix product is 12. 3 times 4. What is the prefix product of 3? That is 2. What is the suffix product? That is 4. What is the prefix product of 4? That is 6. And suffix product, that is 1. Now what we can do? We can just multiply the corresponding prefix product and suffix product to find out the product except self array. So we can just iterate the array and we can multiply 24 into 1. That is 24. If we multiply 12 into 1, that is 12. If we multiply 2 and 4, that will get 8. If we multiply 6 and 1, then we'll get 6. So we find out here product except self array. So we will return this array. For this we have to create 3 separate array: prefix product, suffix product, and for the answer 1. So it will take actually big O of 3n time complexity, that is equivalent to big O of n. And it will take big O of 3n space complexity as well, which is equivalent to big O of n. So here we see that we have maintained our condition and we are not using the division operator to solve this problem. But can we improve this solution? Yes, we can improve. How can we improve? Here we are creating 2 separate array prefix product and suffix product. We don't have to create 2 separate array. We can keep track any one of them, product or suffix product, using only one variable. Okay, first let's talk about how to populate a prefix product and suffix product array. It is simple. Let's see how. By default we'll insert 1 because on the left of 1 we have nothing. So here we have 2. We'll just multiply 1 and 1. So we'll get here 1. And here for 3 we'll multiply 2 and 1. That is 2. And here we multiply 3 and 2. That is 6. So this is how we can construct prefix product. And we can also construct suffix product in the same way. So here we have 4 on the right of nothing. So we'll assume 1 by default. On the right of 3 we have 4. We'll multiply 4 and 1. That is 4. So in case of 2 we'll multiply 3 and 4. That is 12. And in case of 1 we'll multiply 2 and 12. That is 24. So here instead of creating 2 separate array, we can create only one array, either prefix product or suffix product. And we can keep track any one of them using a variable. So for this video I'm going to use a variable for suffix product. Let me clear this out. So let's use a variable here, not an array, to reduce the space complexity as well as the time complexity. So here what we'll do, we'll have the suffix product of 4, that is 1, and we are going to iterate this array from right to left. So what we have on the right of 4, that is 1. So suffix product of 4 is 1. What is the prefix product of 4? Prefix product of 4 is 6 and suffix product is 1. So we'll multiply 6 and 1. So here we have 6. Now we have moved to this element 3. We have suffix product equals to 1, but when we move to the left we have calculated the suffix product. So we'll multiply 4 with 1, and here we'll multiply 2 and 4, then we'll get 8. Let's calculate the suffix product for this 2, right? For moving here we'll calculate the suffix product of 2, that is 3 times 4, that is 12. So we have 12. Now what is the prefix product of 2? So I'm going to multiply prefix product with suffix product, that is 12 into 1, that is 12. Now we find it 12, right? So we'll move to this element. Before moving to this element, we'll calculate the suffix product of 1, that is 2 times 3 times 4, that is 24. So what is the prefix product of 1? That is 1. What is the suffix product? That is 24. So we'll multiply 24 into 1, then we'll get 24. So this is how we can solve this problem. Instead of creating a new separate array, we can use a single variable. So it will take time complexity O of 2n, because we have to iterate the array twice. So it will take a big O of n time, or similarly it will take space complexity as well. It will take O of n times. So this is the optimum solution of this problem. Here we saw that we are not using the division operator to solve this problem. This is the core intuition of this problem. First we find out prefix product array. We are finding out the suffix product array using a variable, and then we are calculating the product except self using the concept of prefix product and suffix product. I hope you understand this, and this is the intuition you need to solve this problem. So now let's see the algorithm first, and I'm going to create an array into prefix product. So prefix product. In this array we have the prefix product for every element, and then we'll store the product except self in this array. So prefix product equals to new, size of this array is the given array, int nums dot length. Now I'm going to construct this prefix product array. So for that, let's insert at the first position of prefix product. So at first position we have to insert the value 1, because for the first element, let's say we have an array 1 2 3 4. For this one we have nothing on the left of this one, so this is the base case. Now let's construct the prefix product. For that I'll be using for loop for int I equals to 1. We are iterating from I equals to 1 because we have inserted already 1 on our 0th position. I is less than nums dot length and I plus plus. Now prefix product equals to, now prefix product equals to, what we have to do, we have to go one step back in our prefix product array. So prefix product of I minus 1 into nums of I minus 1. This is kind of a dynamic programming approach. Okay, so now we have to keep track the suffix product. So let's create a variable int suffix product, but we saw in the picture that will take extra space, so we can reduce the extra space using the suffix product variable. So we have suffix product equals to 1, because on the right of 4 we have nothing. So the suffix product of 4 equals to 1, that is the base case. Now we have to iterate this array from right to left. So for int I equals to nums dot length minus 1, while I is greater than equals to 0 and I minus minus. Okay, now we are going to store the product except self in this prefix product. So we are not going to use extra space, so it will be space efficient. So let's store here prefix product of I equals to, we have to multiply whatever value we have in our prefix product table corresponding to its position. For 4 we will be having prefix product as 6, and the suffix products we will be having is 1. So we don't care what value we have here, we'll just get this value 6. And the suffix product we'll have in the suffix product will be having 1. So we don't care what value we have here, we'll just get this value 6. This is the prefix product and this is the suffix product, and we'll update the value in our prefix product with that calculated values. So prefix product equals to prefix product I times suffix product. Now we have to calculate the suffix product for every single element. Since we are storing in a variable, when we move to this element 3, so when we are done, we have processed this element and we have find out the prefix product we have. And for this element, the product except self is 6. So we have to find out the suffix product for this element. So what we can do, we can just multiply this number and whatever value we have in our suffix product. So suffix product equals to suffix product times nums of I. And here at the end we will return our prefix product array. So this is the solution of this problem. This algorithm will take O of 2n time complexity. We have seen that we are iterating for 2 times, so it takes 2n time complexity, that is equivalent to O of n, and it will also take O of n space complexity for this prefix product array. So this is the algorithm. Now let's run this code. So yes, all the test cases are accepted. Let me submit this code. So yes, it is submitted successfully. So this is the algorithm. So I hope you have understood the problem, and I hope you like this video. If you have any doubt, you can ask me in the comment section, and if you like this video, please like, subscribe and share. Thank you so much. I'll see you in the next one.